Today we're looking at Lesson 2.7, which is on translations and reflections on the coordinate plane. There is a lot of vocabulary for this lesson, and there's also some key concepts, so I would encourage you to turn to page 103 in your textbook to follow along, and I'll try and explain it also. Before we get to this example, I wanted to talk about a little bit what a translation is and what a reflection is. So a translation is, if you think of the word slide, a translation is like a slide from one position on the graph to another. You don't turn it, you just slide it. The image is the same shape and the same size as the original, and same with the orientation, which means you don't flip it, you just keep it the same. You're just sliding it to a different spot on the graph. A reflection is when you flip. You're either flipping it over the x-axis usually or over the y-axis, and they call those the lines of symmetry because they are basically where you're splitting up the image or moving the image from one side to another. The images are the same, but they're kind of like mirror images of each other with reflections. Think of your reflection in a mirror. And the orientation is different, obviously, because you flip it. Okay, so it's going to be, one side is going to be a different orientation than the other. And so we're going to show you a translation and a reflection. Okay, so the first example is, it says triangle ABC is translated so that B is mapped to B with the little dash here. Okay, B with the little dash, that means the image that it's making. So it's after the translation, they put a little dash next to the letter. So B with the capital B right here, that is the original B. So we're trying to figure out which coordinate pairs with the used the wrong word there, with the translated letter C down here. So here's the example. Okay, you see the image is mapped right here, and then you have the image B here with the little dash. That means it's the new B. So you moved the B from its original position, which was 1, 2, 3, 4 at 0, 4, to be at 1, 2, 3, 4, negative 4, 1. So if we look at the difference between these ordered pairs, you have 0 to negative 4, which means it went down 4, and 4 to 1, it means it went to the left 4, and then you have 4 to 1, which means it went down 3. So if we go to letter C, which is here, letter C starts by being 1, 2, 3, 4, 1, 2, 4, 6 is its original position. So if we went down for the x value, or I keep saying down, to the left for the x value 4 spots, we're going to subtract 4 from this 4 to go to, which means to the left 4 spots, and you get 0. And then if you go down 3 spots from the y-coordinate, which is what we did for letter B, we're going to subtract 3 from the 6 to get 3. So our new point for point C should be 0, 3, which I have some possibilities listed here on this part right there. And so letter G was my choice. Now this one is talking about a reflection. It says the vertices of triangle ABC are 4, negative 2, 0, 2, and 5, 2. So I'm going to graph that. So 4, negative 2 is A. B is 0, 2. And C is 5, 2. So here's the original figure. Now it says graph the triangle, which we just did, and its image after a reflection over the x-axis. So if we think about a reflection over the x-axis, the x-coordinates are going to be the same, but the y-coordinates are going to be opposite. If we were to do a reflection over the y-axis, the y-coordinates would be the same, but the x-coordinates are opposites. So in this case, we're doing a reflection over the x-axis. So that means the x-coordinates will be the same, but the y-coordinates are going to be opposites. So here are our coordinates. We have 4, -2. We have 5, 2. And we have 0, 2. So all of our x-coordinates are going to be the same. It's just we're making the opposites for our y-coordinates. So if we're going to do B, the opposite of y is -2. So my new B is going to be 0, -2. And they indicate it with a little dash. My new C is going to be 5, -2. Because the x's stay the same, the y's are opposite, and my new A is going to be 4, +2. So I just did the opposite of all the y-coordinates. Now I'll regraph my new image. 0, -2 is going to be here. 5, -2 is going to be here. And 4, 2 is going to be here. So this would be the image flipped over the x-axis. And that concludes lesson 2-7.